which means we're going to follow the same diagram I wrote a little bit ago in the previous problem. This one says you have 60 milliliters of 0.1 molar sodium hydroxide. That's how much is required to neutralize 15 milliliters of H2SO4. What is the molarity of the H2SO4? Okay. So we're looking for the molarity of H2SO4. It says write the balanced equation for the reaction. So let's do that first. That'll probably help us. Again, I'm going to zoom in. So we have NaOH and H2SO4 reacting together. NaOH plus H2SO4. This is actually an acid-base reaction. Here is our base. Remember, a metal and hydroxide is a strong base. And then we have the hydrogen and the rest of the acid. So this is the acid. In an acid-base reaction, remember, we always make water. H2O is one of our products. And looks like sodium sulfate is going to be the other one. Okay. So it needs to be balanced. Is it balanced? I don't believe that it is. If I need 2 sodiums. Now I have 2 oxygens, 2 4 hydrogens, so then I think if I put a 2 here, I think we're good now. Okay. So now we've written the balanced reaction. Now reread the problem and remember how we used that diagram and we said volume of substance A, molarity of substance A, mole ratio between substance A and substance B. Go through and label what is substance A and what is substance B. You're going to start with the information given for substance A. And in the previous problem I said whichever compound it gives you both a volume and a molarity for, that is substance A. Okay, so that's A, and then the thing it's asking for, this is what we're going to label as substance B. And now we just follow that diagram. Okay, so we're going to start with 60 milliliters of NaOH. And we have 0.1 molar NaOH, so that is like saying, erase. Remember, 0.1 molar, that's like saying we have 0.1 moles per liter. That's what molarity is. And so because we have units of liters in this relationship and not milliliters, we have to first convert our milliliters down here to liters. And that will be of NaOH. Now we can use the molarity given to go from volume to number of moles. So I'm going to plug in what I wrote up there in blue so that liters cancel out. Liters on bottom, for every 1 liter we get 0.1 moles of NaOH. Okay, so far milliliters cancel, liters of NaOH cancel, now we have moles. Now we can use a mole-to-mole ratio, which is what? Between NaOH and H2SO4, it's a 2 to 1, so for every 2 moles of NaOH, we need 1 mole of H2SO4. Okay. Now the question here is let's reread the actual question part. It says, what is the molarity of H2SO4? What is the equation for molarity? Let's write that out down here at the bottom. Molarity, capital M, equals moles over liters. we're given volume. We need to convert this to liters of H2SO4. And if we stop our problem right here, this big long one we've been doing the stoichiometry for, guess what our answer will be? Moles of H2SO4. Because moles of NaOH cancel. And if we have moles of H2SO4 and we have liters of H2SO4, we can calculate the molarity. So that is what we're going to do. This big long conversion problem we've been doing, I'm going to solve for the answer. So 60 milliliters divided by 1,000 times 0.1 divided by 2, you should get 0.003 moles of H2SO4. Okay, so I'm going to zoom in so I write a little smaller. So we're going to do the next step. We're actually going to solve for molarity here. Molarity equals, there's our top part, 0.003 moles of H2SO4. We've got to divide that by liters. We have 15 milliliters. Take that number, divide by 1,000 to convert to liters. And when you do, you should get 0.015 liters. Molarity is moles divided by liters. So if we do this, 0.003 divided by 0.015, you should get a molarity of 0.2. We'll do capital M. And this is our answer for the problem. Okay? It said, what is the molarity of H2SO4? And we have solved, it's 0.2 molar. Okay, so this second problem was different from the first up here. And in this problem up here, we were looking for a volume, how many milliliters. And in this problem down here, we were trying to calculate a molarity. So, I consider these to be some of the more challenging problems for exam 3. So keep that in mind as you prepare. This problem looks all too familiar. Did I literally have it on the review 3 times? I think I did. I think we've already solved